Above us, in the shoulder of Orion, a star waits, one of the brightest in our night sky, a red supergiant on the brink of cosmic collapse. This is Betelgeuse, a dying giant, a star so large that if it replaced our sun, it would engulf Mercury, Venus, and even Jupiter. But lately, something strange has been happening. Betelgeuse has dimmed unexpectedly, leaving astronomers scrambling for answers. Why has this massive star fluctuated so wildly? What forces are tearing at its core? And how close is it to its inevitable end? Some say Betelgeuse could explode tonight, others centuries from now. But one thing is certain, the clock is ticking. Long before telescopes gazed into the depths of space, long before modern science gave us names like supergiant or fusion, there were stories whispered beneath ancient skies. For thousands of years, Betelgeuse, this faintly flickering red star, has captured the curiosity of humanity. Early civilizations from Egypt to Mesopotamia stood beneath the heavens and noticed something odd. Among the glittering blues and whites of other stars, Betelgeuse glowed like an ember, burning with a deep, blood-red hue. It didn't just twinkle, it pulsed, it breathed. It told them, this star was special. The Babylonians included it in their celestial lore, placing it within their constellation known as the true shepherd of the sky. The Greeks later reimagined it as part of the hunter Orion, forever locked in battle against Taurus, the bull. But it wasn't just the mythology that gave Betelgeuse its allure. In ancient Arabic astronomy, this red star was so distinct that it earned a name that would travel through time. Originally called Ib al-Jawza, meaning the armpit of Orion, or more commonly translated as the shoulder of the giant, the word Ib became corrupted through centuries of transliteration, evolving into the modern name we know today, Betelgeuse. It is a name steeped in history, a linguistic artifact linking today's scientific marvels to humanity's earliest attempts to map the heavens. As astronomy entered its golden age, Betelgeuse's mysteries only deepened. It wasn't just its color that set it apart, it was its location, magnitude, and temperament. Positioned roughly 650 light-years from Earth, Betelgeuse sits at the top left corner of Orion, marking the hunter's massive right shoulder. From this perch in the sky, Betelgeuse has served as a cosmic landmark across cultures and eras. In the northern hemisphere, Orion dominates the winter night. Betelgeuse, casting its ruby glow, stands as one of the most noticeable stars to the naked eye, often rivaling the nearby Rigel with its icy blue shimmer. But early astronomers noticed something else. Unlike the steady brilliance of Rigel, Betelgeuse was erratic. It brightened and dimmed over time, an unpredictable dance that confounded scholars and storytellers alike. In the 16th and 17th centuries, as telescopes began to unlock the secrets of the stars, Betelgeuse became a scientific curiosity. Astronomers began to record its fluctuations, suspecting that something within this crimson giant was unstable. But the true scale of Betelgeuse wouldn't be realized until the dawn of modern astrophysics. In the 19th century, scientists using spectroscopy identified its spectral signature, confirming it as a red star, cooler than the sun, yet somehow impossibly larger. By the early 20th century, Betelgeuse became one of the first stars where astronomers estimated its immense size. For the first time, humanity realized they were looking at a true titan, a supergiant whose surface, if placed where the sun is, would stretch beyond the orbit of Jupiter. It was monumental, a revelation that rewrote our understanding of stellar evolution. Stars, it turned out, could swell to incomprehensible proportions in their old age. And yet, the mystery only grew deeper. Betelgeuse wasn't simply vast, it was unstable. Pulsating, shedding mass, and drifting ever closer to the inevitable fate of all supergiants, collapse and supernova. From ancient skywatchers to cutting-edge telescopes, Betelgeuse has remained a star that refuses to be forgotten. It has been a guide, a myth, a curiosity, and today a ticking time bomb. 650 light-years may sound far, but in cosmic terms, it's close enough to make Betelgeuse not just an object of fascination, but of personal relevance. It is a reminder that stars live, and stars die. And some stars leave a light so bright, it echoes across the ages. To understand Betelgeuse, you need to first understand scale. Our sun is enormous by human standards, vast enough to fit 1 million Earths inside it. But Betelgeuse laughs at those numbers. If Betelgeuse replaced our sun, its swollen atmosphere would stretch out to Jupiter. Everything inside the asteroid belt, swallowed whole. This red supergiant is nearly 950 times wider than our Sun, and up to 20 times more massive. But its size alone isn't what makes Betelgeuse strange. It's the way it behaves, because this ancient star is spinning faster than it should. Betelgeuse's equator is rotating at around 18,000 kilometers per hour. For a red supergiant, that's fast. Far too fast. Stars this massive should spin slowly, their bulk dragging on their momentum as they bloat and age. So, why is Betelgeuse still racing? Astronomers have two theories. The first is cannibalism. Some scientists believe Betelgeuse swallowed a smaller companion star millions of years ago. That stellar snack could have injected enough angular momentum to speed it up, and may explain why Betelgeuse is so turbulent today. Others think we might be misreading the star altogether. Betelgeuse's surface is churning with convective storms, giant waves of plasma rising and falling. These turbulent flows might be tricking us, creating false Doppler effects that make Betelgeuse appear to spin faster than it really is. Whatever the cause, Betelgeuse is a cosmic anomaly, a bloated, fast-spinning titan on the brink of destruction. The question isn't whether it will explode, but when. In late 2019, the night sky changed. Amateur astronomers and professionals alike noticed that Betelgeuse, one of Orion's brightest stars, was fading. Night after night, it grew dimmer, its signature reddish glow fading into a pale orange. What the world was witnessing would soon be known as the Great Dimming, and it left astronomers scrambling for answers. At its peak, Betelgeuse dimmed by nearly 40%, an unprecedented drop for a star this famous and nearby. For a moment, Betelgeuse slipped from the top 10 brightest stars in our sky. Theories ran wild. Was this the precursor to the supernova astronomers have been predicting for centuries? Had Betelgeuse's core finally collapsed? Some speculated this was at the death throes of a red supergiant, seconds away in cosmic terms from the supernova of the millennium. But reality, as always, was more complex. Soon, more grounded explanations emerged. The leading theory? A massive surface ejection of gas and dust, hurled from Betelgeuse's outer layers. This material, upon cooling, formed a dense cloud that temporarily blocked the star's light, almost like Betelgeuse shrouded itself in a cosmic veil. Much like a volcanic eruption on Earth can darken the skies for weeks or months, Betelgeuse's ejection created an uneven blanket of dust that drifted between us and the star. The result? A dimming visible from across the galaxy. Another theory pointed to giant star spots, vast regions of cooler, magnetically active surface. On our Sun, sunspots appear dark by comparison. On Betelgeuse, these star spots would be monstrous, capable of covering a significant portion of the star's enormous surface and dimming it from our perspective. Stars like Betelgeuse experience chaotic surface activity. Some researchers suggest that these star spots combined with the dust cloud to create a perfect storm, an overlapping of phenomena that made Betelgeuse dim far more than it ever had before. Meanwhile, the public's imagination ran wild. Could we be about to witness a supernova? Would we see a second sun in the sky? The internet buzzed with speculation, excitement, and a touch of cosmic fear. Despite the buzz, most experts advised patience. Betelgeuse's lifespan, even in cosmic terms, could see it last another 100,000 years. Yet this mysterious dimming reminded us just how alive and unpredictable the universe really is. By mid-2020, Betelgeuse began to brighten once more. The dust cloud thinned, drifting out of our line of sight. The great dimming was over, for now. But the questions it raised remain. What caused such an enormous ejection? Could this instability signal that Betelgeuse is closer to collapse than we thought? Or was this merely a glimpse into the chaotic heartbeat of a dying star? One thing is certain: Betelgeuse is a ticking time bomb. Whether its finale comes tomorrow or long after humanity is gone, the star's strange behavior is a reminder. In the cosmos, even the brightest giants can surprise us. Betelgeuse is a dying star. A giant standing at the edge of cosmic oblivion. But to understand what's happening deep inside its fiery core, we must first understand how stars live and how they die. Right now, Betelgeuse is in the final chapters of its life. It's burning through its fuel at an astonishing rate, rapidly fusing helium into carbon and carbon into neon. This is a process that only the biggest stars in the universe go through, the kind of stars that live fast, burn bright, and die young. For millions of years, Betelgeuse fused hydrogen into helium. But once the hydrogen ran out, gravity took over, compressing the core until it ignited helium fusion. That stage is behind us now. Today, Betelgeuse is burning through carbon and neon like there's no tomorrow, racing toward its inevitable fate. After carbon comes neon, then oxygen, and finally, silicon fusion. Each stage shorter than the one before. These late-stage fusion processes aren't leisurely, they happen over thousands or even hundreds of years. In fact, when silicon fusion begins, it will last mere days before the star collapses. But there's a limit to fusion. A point where even stars cannot cheat nature. That limit is iron. Once iron forms in the core, the star hits a cosmic dead end. Unlike lighter elements, iron doesn't release energy when it fuses, it consumes it. At this stage, gravity begins to win the long war it has been fighting against radiation pressure. For millions of years, fusion has pushed outward, holding the star up, resisting collapse. But once iron takes center stage, fusion shuts down. There's no more fuel to fight back against gravity's crushing grip. The delicate balance between gravity and radiation pressure collapses. The core, once the powerhouse of Betelgeuse, will implode, shrinking in less than a second to a fraction of its size. What follows is an unstoppable shockwave. This is the supernova we've all been waiting for. A cataclysm so bright it will be visible from Earth during the day, shining like a second sun in our skies. But right now, the star remains locked in its death spiral, inching closer to this cosmic event. Astronomers worldwide are watching. In 2019, Betelgeuse dimmed unexpectedly, sparking rumors that the end was near. But follow-up studies revealed it was likely due to a massive dust cloud obscuring its light, not its core collapsing. Still, the clock is ticking. Betelgeuse has less than 100,000 years left to blink in cosmic time. And when you consider the 650 light-years between us, it's possible the star has already exploded, and the light simply hasn't reached us yet. Betelgeuse's struggle is a battle fought in silence, in deep space, hidden inside layers of nuclear fire. Yet its fate is sealed. The fusion furnace will soon run out of tricks, and gravity will have its final say. What we are witnessing is not just the slow death of a star, but the setup for a cosmic rebirth. One day, this ancient giant will scatter its heavy elements, carbon, oxygen, iron, across space. The building blocks for planets, for life, for us. Betelgeuse's death will seed the galaxy. And long after its light fades, its legacy will live on in the worlds it helps create. The end is near. But in space, endings are never the final chapter. At the heart of Betelgeuse, time is running out. Like every massive star, it's fighting a losing battle against gravity. This is where stars become something more. Something violent. Something beautiful. This is where a supernova is born. In stars like Betelgeuse, nuclear fusion has kept gravity at bay for millions of years. Layer by layer, element by element, the core fuels the star's existence. But when it reaches iron, fusion stops. Iron consumes energy. And suddenly, gravity wins. The core collapses in a heartbeat, shrinking from the size of a planet to that of a city. In less than a second, densities soar beyond imagination, creating one of the strangest objects in the universe, a neutron star. For stars like Betelgeuse, the sudden bounce of the neutron star sends a shockwave tearing through the star's outer layers. The result? A supernova. To us, it would appear as a sudden, blinding light in the night sky. A beacon that could shine brighter than the full moon, perhaps even brighter than the stars themselves have ever appeared in human history. In 1987, astronomers witnessed the brightest supernova in centuries, SN 1987A. It lit up the southern hemisphere skies and transformed how we understood stellar death. But Betelgeuse? It would be far closer, far brighter. A once-in-a-lifetime event, maybe. Unlike distant supernovae, Betelgeuse would be so bright, we'd see it during the day, for weeks. At night, it would rival the glow of the full moon, casting shadows, changing landscapes, and illuminating our skies with a new, ghostly glow. But should we be afraid? Would the energy from such a colossal explosion threaten life on Earth? The short answer is no. At 650 light-years away, Betelgeuse is too distant to harm us. The radiation, the shockwave, by the time it reaches Earth, it will be like a soft cosmic breeze, not a battering ram. What we will witness is transformation. The death of a star birthing new elements, gold, platinum, oxygen, carbon, flung into space to one day form planets and life. And yet, as you listen to this, Betelgeuse still hangs quietly in Orion's shoulder. A star on death's doorstep, but not yet crossing the threshold. Could we witness the brightest object since SN 1987A? Or will Betelgeuse keep us waiting for another 1,000 years? Out here, time moves differently. Out here, the universe has its own clock. Today, Betelgeuse remains under constant surveillance, a celestial ticking clock that astronomers around the world refuse to ignore. From ground-based observatories in Chile to space telescopes orbiting above Earth's atmosphere, the hunt for Betelgeuse's secrets is intensifying. The Hubble Space Telescope continues to monitor this giant's behavior, searching for telltale signs, like gas clouds, turbulent outflows, and strange pulsations. When Betelgeuse dimmed unexpectedly just a few years ago, it triggered an international alert. Was this the precursor to its supernova? Or just another turbulent storm in its fiery atmosphere? Meanwhile, the Atacama Large Millimeter/Submillimeter Array, ALMA, peers into the star's cooler layers. It has revealed colossal convective cells on Betelgeuse's surface, each large enough to swallow entire planets. Using radio waves, ALMA tracks the slow, uneven shedding of Betelgeuse's outer layers. These dusty veils could eventually cloud the supernova flash, or mark the star's final breath before collapse. And now, the James Webb Space Telescope joins the search. Its infrared sensors are perfect for piercing the dust and gas surrounding Betelgeuse, allowing scientists to see deeper into the supergiant's roiling heart. But optical and infrared light are only part of the story. To catch the first true signal of Betelgeuse's death, we'll need to listen for something much harder to detect. Neutrino detectors, buried deep underground, stand ready. When Betelgeuse's core collapses, it will unleash a storm of neutrinos. They'll arrive at Earth before the light of the supernova ever reaches us, giving us hours, perhaps even days, of advance notice. Right now, astronomers monitor Betelgeuse daily, watching, waiting. Because out there, 650 light-years away, the final clue might already be racing toward us, traveling faster than any telescope can detect. When that signal arrives, what will we see? Will we witness the grandest fireworks show the human race has ever seen? Or will it happen quietly, unnoticed as the world sleeps? One thing is certain, whether in our lifetime or far beyond it, Betelgeuse's final act will be worth the wait. Betelgeuse, the unpredictable red supergiant, an ancient titan, perched on the edge of oblivion. It has held humanity's gaze for centuries, quietly waiting in the night sky. Yet here we are, still unsure of its fate. Astronomers have monitored its dimming, measured its violent storms, and debated its unnaturally fast spin. Is Betelgeuse nearing its explosive finale, or will it continue burning for another 100,000 years? We stand in awe of a star that could, at any moment, outshine the full moon, create shadows at midnight, and briefly rewrite the canvas of our sky. But as with all things cosmic, patience is required. For now, Betelgeuse remains a ticking clock in Orion's shoulder. An unanswered question. A cosmic riddle hidden in plain sight. But what do you think? Will Betelgeuse explode in our lifetime? Or will it leave its fireworks for future generations? Leave your predictions in the comments below. And don't forget, subscribe for more journeys into the strangest stars in the universe, before this red giant vanishes forever.